Hello students, myself Dr. Rajesh, working as assistant professor in mathematics in GMN College, Ambala. So that is full form of the college is Gandhi Memorial National College, Ambala Kent. So I am working there as assistant professor in the subject of mathematics, and I have been teaching their subject of mathematics to undergraduate and postgraduate classes. So today I will discuss with you an important topic of mathematics belonging to the undergraduate classes, and the name of the topic is reduction formula. Now firstly we shall see what is reduction formula. So reduction formula, it is the formula that connects the given integral with the integral of same type but simpler one. Simpler one means which is easier to integrate. Simpler one means which is easier to integrate. So now see what is reduction formula. It is the formula that connects the given integral, whichever integral is given to us, we will connect this integral with some other integral of simpler type, and the other integral will be the same as the given integral. Like for an example, I am going to write 10 raised to the power nx dx. Okay, and we are asked to find its reduction formula. Find its reduction formula. Like we are given 10x raised to the power n, so we may name this integral as I raised to the power n, I subscript n. So I subscript n means this is indicating the power of or indices of 10x. Now this is 10 n minus 2 x 10 square x. Can we split the integral in this form? Okay, now this 10 n minus 2 is written separately, and this 10 square x is written separately. So when we will add up these two, so this will come back to 10x raised to the power n. So this splitting can be very much done legitimately. This is a valid step where we have written 10 raised to the power n 10 raised to the power n as 10 raised to the power n minus 2 10 into 10 square x. Now we have to integrate it. We know the formula for 10 square x. You would also be knowing secant square x minus 10 square x is equal to 1. So from this implies that from here 10 square x is equal to secant square x minus 1. So we are going to replace this formula over here so that we could integrate it. Okay, so this will be the replacement 10 raised to the power n x into secant square x minus 1 dx. Now see, we will now multiply. Okay, we will multiply it, and this will be multiplied, and this will be written something like 10 n minus 2 x secant square x dx minus 10 n minus 2 x dx. Okay, now see, integration of 10 differentiation of 10x is equal to secant square x. Okay, so now this 10 will behave as if 10 t raised to the power n minus 2 dt. Okay, and you know the integration of this one is t raised to the power n minus 1 divided by n minus 1. So here its differentiation is present over here, so this will behave as if t. Okay, so you know its integration will be 10 n minus 1 x divided by n minus 1, okay, minus, and this is the integral of the same given type na, but of simpler one in the reduced one, or simpler one in the sense that the given integral was having power n, and now this integral is having power n minus 2 na. So we have got the given integral related to the simpler integral in the sense here power is n and now here power is n minus 2. So this is simpler integral na. So we may write it in the same way as I n minus 2. So this implies that I n is related to 10 n minus 1 x divided by n minus 1 minus I n minus 2. Okay, this is the required reduction formula for 10 nx dx. Okay, and you may name it as equation number 1. Okay, so this is done. So we have find the reduction formula. Now if he further asks that on the basis of the reduction formula, hence find the value of integral 10 x raised to the power 3. So we are asked to find the value of 10 cube x using the reduction formula number 1. So by the given notation, this will be I3 na, the notation used in the above reduction formula. So using the equation number 1 now this equation number 1, if we put n is equal to 3 here, so this will be 3 minus 1, it will be 10 square x, and it will again will be 3 minus 1, it will be, this is again 2, this is minus, and again see this is 3 minus 2, it will again be I1. Okay, so this will be 10 square x by 2 minus, now what is the value of I1 by the notation? This will be 10x raised to the power 1 dx. Now integration of the 10x you all know is equal to 10 square x by 2 minus log of secant x. Okay, so this is the required value of I3, and which is nothing but 10 cube x dx. So look how easily we have find out the value of I3 within 1 or 2 minutes na, using the its reduction formula. So the reduction formula is helpful in this sense that the value of the integral could be found out very easily, as we have demonstrated here. Firstly we determine the reduction formula for 10 raised to the power n, and which is given by equation number 1, and then on the basis of this we have find out the value of 10 cube x. Okay, it was very easy na. So that is why reduction formula is called the reduction formula. Look here, the power of the integral is n, 10 raised to the power n. Okay, now here the power is n minus 2. So we have connected the given integral where the 10 is having power n to the integral simpler one now where 10 is having power n minus 2. So this connection is called the reduction formula because the power have been reduced and reduced to n minus 2. So hence its name na reduction formula, because the power or the type of the integral has been reduced to a simpler one na. In this case the integral was involving 10 raised to the power n, 10 raised to the power n. Now in this it will be involving n minus 2 only. So hence the name it's a reduction formula. Now we will find the reduction formula for one more integral. Okay, and that integral will be also of this that kind. Let us say find the reduction formula, find the reduction formula for secant n x dx. Okay, now let this integral is again written as I n, okay, secant n x dx. Now see, this was having power n, so we have written n as its subscript. So it is very much clear, if here is power n, so here its subscript is n. So here only one variable index is involved, so we have written only n over here. In future if there will be two indices, different indices, in this case we will be writing n comma m in the subscript notation. Okay, now for the time being we are having only one only n as variable that could be changed. Okay, so we have written subscript n only. Now we know that this can be written as, further can we write it legitimately something like that? Can we write it something like that? Yeah, again you see this is power n minus 2, this is power square, so this is when added will give back to secant n, okay, secant x raised to the power n. Now see, we have to just integrate it. Now we invoke to the integration by parts. In integration by part, the function which can be integrated is assumed as second function na. So in these two functions, this is the only function which can be integrated and its integration will be 10x na. So this will be assumed as first function. We have no option, sorry, second function. We have no option to assume it as second function. And now look over here, this function can be differentiated only but cannot be integrated, and in integration by parts the function which is differentiated is to be assumed as function number 1. So this is how we have to make this selection between first and second function. First function will be assumed as the function which cannot be integrated na. So in this case secant x raised to the power n minus 2 is the function which cannot be integrated but it can be differentiated, so it is assumed as a first function. But this function, look over here, this function has integration which is 10x, okay, and it can also be differentiated, but that function could not be integrated, so it got the position 1. So this function has no option, its integration is possible, so this function is assumed to be second function. Now carry out the integration by parts. Integrating by parts, we get, yes, what we will get, first function as such, going to do the integration by parts, integration of the second function, okay, very much clear. Now minus, now differentiation of the first function, differentiation of the first function and integration of the second function and the integration of the whole thing. Now I am going to put these integrals value. You know this integral is equal to 10x minus this will be n minus 2, this will be secant n minus 3 x into secant x 10x, okay, done, into, and this integral will be 10x and this is over whole dx, okay. Now this will be again equal to secant n minus 2 x 10x n minus 2 integral secant n minus 2 x, this is 10 square x dx, okay. We have just collected the same terms. Now this will again be equal to secant n minus 2 x 10x minus n minus 2, this is secant n minus 2 x, and you know this is equal to secant square x minus 1 dx, okay. So this is further equal to secant n minus 2 x 10x minus n minus 2, and this will be secant raised to the power nx dx, this is plus n minus 2 integral secant n minus 2 x dx, okay. Look over here, what we have done, we have multiplied it inside this one. So this n minus 2 will be secant x raised to the power n, okay. When this is multiplied by this one, this minus will change to minus, minus will be plus na, so here is plus sign and n minus 2 as such, and this secant n minus 2 is here. Now we are going to use the subscript notation, okay. In subscript notation, this is equal to minus n minus 2 and this is in, this is plus n minus 2 and this is equal to in minus 2. So this is also equal to n. Now see, here is in, okay, and here is also in. So what we do, we collect these two into left hand side. So this process of taking this over here is called transposition, okay. Transposition means we will take it over here. So this will be in plus n minus 2 in is equal to secant n minus 2 x 10x plus n minus 2 I n minus 2. Now see what we do, we are going to take this as in 1 plus n minus 2 is equal to secant n minus 2 x 10x plus n minus 2 I n minus 2, okay. So this is further equal to n minus 1 is equal to secant n minus 2 x 10x plus n minus 2 I n minus 2. This will go down there, in is equal to secant n minus 2 x 10x divided by n minus 1 plus n minus 2 n minus 1 I n minus 2. So this is the required reduction formula in which in is connected to in minus 2. Okay, so this is the required reduction formula. So you are just going to name this equation as equation number 2. So this is the reduction formula. Secant x raised to the power n integral is connected to secant x raised to the power n minus 2. Simpler one. This integral is simpler one. This is the given integral. So once again we are verifying the definition of the reduction formula. Okay, now this is what we have done. Okay, now basis upon this, hence find the value of secant 6x dx. Okay, now this integral can be written in the subscript notation as I6 secant x dx. Okay, now using the equation 2 for n is equal to 6, here will be 6 minus 2 4, so you will write it as a secant 4x 10x as such. Okay, done. And it will be 5 na, 6 minus 1 is 5 plus 4 by 5, and it is I. What will you do? You will write here as I4, and this equation is named as 3. Now I4 is again calculated by this formula number 2 with n is equal to 4 now, with n is equal to 4. So we are going to use the formula number 2 again to find I4. Okay, I4 is equal to, now the formula number 2 for n is equal to 4, this will be secant square x, this is 10x divided by 3, okay, plus 2 by 3, and here will be I2 na. So this is further equal to secant square x 10x by 3 plus 2 by 3, and this can be written as secant square x dx. And you all know na, formula for secant square dx and is 10x now, because secant square x is having integration which is 10x. Okay, and name it as equation number 4. Put 4 in 3, we get, yes, what will get? Now substitute it. This will be I6 will be secant 4x 10x by 5 plus 4 by 5, and I4 is secant square x 10x divided by 3 plus 2 by 3 10x. Okay, now this will be multiplied and written as secant 4x 10x divided by 5 plus 4 by 15 secant square x 10x plus 8 by 15 10x. So this is the required value of I6, and I6 was equal to secant x raised to the power 6 dx. So therefore we have find out the value of secant raised to the power 6. So this was this. Now you have seen with the help of the reduction formula, number 3, how easily we were able to find out the value of secant x raised to the power 6. So this is what we call it as the deduction, where we have put the value of n as 6 and find out this one. Now 6 has been reduced to 4. Okay, again in equation number 2 we have put n is equal to 4 and written this integral, and I2 was very simple to calculate. This has a simple 10x. Now 4 is substituted back into 3, so we get the required value of I6. So this is how reduction formula can be useful. Now next we have to find the reduction formula. Say find the reduction formula, find the reduction formula for log x raised to the power n x raised to the power m dx. Okay, so this integral can be written as I n comma m. Now look, here are two indices. One index is of log x and other is of x. So we have written in the subscript notation both the indices n and m. So this is in the subscript notation, and I stands for integral sign. Okay, x raised to the power m dx. Now see which function to assume as first and second. See, this log x raised to the power n cannot be integrated at all, but it can be differentiated. Therefore, this function is assumed as first function. But this function x raised to the power m can be integrated. Therefore, this function is assumed as function number 2. Now, integrating by parts, we get, now use the integration by part. This n comma m is equal to log x raised to the power n will remain the same, while x raised to the power m will be integrated. Okay, minus this will be n into log x raised to the power n minus 1 into 1 by x into x raised to the power m plus 1 divided by m plus 1, and here is dx. Okay, this x will cancel from this power 1. Okay, now in the next step, this is equal to log x raised to the power n x raised to the power m plus 1 divided by m plus 1 minus n. Constants are out of the integral sign. Log x raised to the power n minus 1 x raised to the power m dx. Now see how this thing will work. This is further written in the subscript notation as log x raised to the power n x raised to the power m plus 1 m plus 1 minus n m plus 1, and this can be written in the subscript notation n minus 1 comma m, and this is I n comma m. Now see, here you see, here was n and n is reduced to n minus 1. Log x indices is reduced to n minus 1. M x raised to the power m, here is same x raised to m. So only one index is reduced, that is n to n minus 1, and m is remaining constant. So this is the required reduction formula where only one index is reducing, and with the help of this reduction formula, the sum reduction can easily be made, like we did in case of secant x raised to the power n, and after finding its reduction formula we have determined the value of secant x raised to the power 6. Now in the next we will find the reduction formula. RF is short notation for reduction formula, stand for reduction formula for integral x raised to the power n ex dx. Now this is in is equal to integral x raised to the power n e raised to the power x. Now see, in the subscript notation we have written only x raised to the power n index. E raised to the power a index is not written. It is not written as a is not going to change. If we differentiate it, a is not going to make any change, undergo any change, like it will be this one. If we integrate it, it is not going to change at all. It is not going to either reduce or increase in any way. So there is no need to add it into the subscript notation if it is not going to undergo any change. So in the subscript notation we have written only n. So as we have to find the reduction formula, here it is point to be given attention that if you have to find the reduction formula, so this power of x which is n must be reduced, and this will be reduced only when the first function will be differentiated and this function will be named as second function. It will be integrated. Okay, now integrating by parts, we get in is equal to x raised to the power n e raised to the power x by a minus integral dy dx xn e raised to the power ax by a dx. This is further equal to x raised to the power n e raised to the power x by a minus n x raised to the power n minus 1 e raised to the power ax by a dx. Okay, now I am going to take these constant quantities out of the bracket. This is minus na x raised to the power n minus 1 e raised to the power ax dx. Okay, fine. Now I am going to write in the subscript notation. This is further equal to x raised to the power n e raised to the power ax by a minus na I. Now see, here was the power x raised to the power n. Okay, now x raised to the power n have been reduced to n minus 1. E raised to the power x is same. Okay, now so in the subscript notation I am going to write over here n minus 1. Okay, so this implies that in is equal to x raised to the power n e raised to the power ax by a minus n a I raised to the power n minus 1. So this is the required reduction formula. See, in this formula n has been reduced to n minus 1, hence the reduction formula, because its index of x has been reduced from n to n minus 1, hence the name reduction formula. So student, today we have studied what is reduction formula, why it is named as reduction formula, and we have also derived 4 reduction formula for different integrals like tan x raised to the power n x, number 2 secant n x dx, number 3 it is log x raised to the power n x raised to the power m dx, and number 4 e raised to the power ax into me x raised to the power n. So we have studied these 4 integrals, okay, derived their formulae, and also find the value of some specific integral like tan cube x integral and secant 6x integral based upon the reduction formula of secant x raised to the power n and tan x raised to the power n. That was the deduction, and how simpler was it to find the value of this two integral using the reduction formula. So this is the importance of the reduction formula. It makes the complicated integral very simple, look very simple. So in today's lecture we have discussed what is reduction formula and also justified the name why it is given reduction formula. So we also justified its name and also derived the reduction formula these four integrals. Okay, and so and also find the value of these two integrals based upon the reduction formula of these two integrals. So that also highlights the importance of reduction formula, that how the complicated integral could easily be solved with the help of its reduction formula. So this is enough for today's lecture. Very soon I will come up with my second video on reduction formula, where we will find the reduction formula of different new integrals, and we'll take this reduction formula topic to the next level. For the time being, you are expected to go through this lecture and try to understand the concept of reduction formula, why it is called reduction formula, what is the importance of reduction formula, and try to derive the reduction formula of these four integrals. And till that, I expect you to just grasp this idea, and I would also like to thank to my student for your patience and kind attention who are present in the far corner of the world. Besides that, I would also like to thank to my college for providing me this opportunity and platform to interact with my students. Thanks GMN College. And till I come up with my second video, take care, bye bye, and this is Dr. Rajesh.